Have you ever wished that your headphones would automatically untangle so that you didn't have to go through the frustration of fiddling with them? That with a simple click of a button, a material could change from one configuration to another with little interference by the user?
Well, with the help of shape memory polymers, this technology may soon exist. Shape memory polymers, also known as SMPs, are frequently referred to as actively moving or having a memory. But what does that really mean?
These materials are able to shift from one physical state to another. When these polymers are formed, they are programmed to have a permanent shape. Then, by taking advantage of elastic properties, the polymer can be mechanically deformed into a temporary shape. And because they are reversible, the application of a stimulus can cause the material to go back to its original position.
Here is a depiction of the polymer on a microscopic level. Initially, the polymer is formed in its permanent position using programming technology. Then, through mechanical deformation, the polymer can be stretched into a longer but narrower temporary shape. When the stimulus is applied, the reversible properties of the material allow it to be reconfigured to its permanent position, which is shorter and wider. This process is aided by the presence of crosslinks, which are permanent connections between polymer chains, such as covalent bonds, permitting the material to be mobile without risk of degradation. So, what exactly can be used as a stimulus?
The most common type of stimulus used is heat, which can put the polymer above its transition temperature. Additional options include applying a small voltage or flashing a light on the polymer at a particular wavelength. Common materials like polyurethane or polyester can become SMPs simply through the processing method used.
A clear example of stimulus use is shown here, where a shape memory polymer is used to remove a blood clot by being attached to the end of a catheter. The polymer begins in its temporary position as a straight line, which is easy to move through narrow veins in the body. When a small voltage is applied, it immediately reconfigures the polymer into a spiral shape. The wider radius of this shape will allow the clot to be pulled out of the vein and permit blood to flow through once more.
Currently, shape memory polymers have a promising future in medical applications. In addition to removing blood clots, these materials have potential for use in self-tightening sutures, dental molds, and casts in order to allow greater personalization so that patients can have perfectly fitted products.
And who knows, maybe it will help you untangle your headphones someday. With many intriguing capabilities, we hope you enjoyed learning about this polymer class with incredible potential, shape memory polymers.